Alright, this is a problem 12.5, problem number 6. This problem is dealing with a pair of dice, and we're looking for probabilities of all these different things. So, remember, we're computing these classically, getting a pair of dice, or a pair of dice to have a sum, or a pair of fours. So this is basically every single possible outcome that can happen here, right? This is what the sums are: 2, 3, 4, 5, and these are the ways the sums can happen. So if you count these up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. If you count them all up, there's 36 total outcomes here, right? And again, that's coming from that counting principle. 6 for the first die, 6 for the second die. So there's a total possibility of 6 times 6 or 36 outcomes, right? And these are what all those outcomes sum to, is 2, 3, 4, 5, 6 over here on this side. All right, this first question asks us, what's the probability we get a pair of fours? All right, well, where are they? It's the pair of fours. That's the only pair of fours that we have here that are possible, is those two right there. And that's one outcome out of all 36 possible outcomes. So using that classical approach, that's 1 out of 36 for the pair of fours. Alright, then it says, what's the probability of getting at least 1 5? Alright, and going back to this, at least 1 5, there's one that has a 5 in it. Alright, so there's 1. Alright, here's 1, 2, alright, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, those are all at least 1 5. Exactly 1 5. And then this one had 2 in it. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 out of the 36 have at least 1 5 show up in there. So that's 11 out of 36. What's the probability of getting sum of 11? Alright, back to our picture. These are the sums of 11. I can get a 5 and a 6, or I can get a 6 and a 5. It's important you understand those are two different possible outcomes. Alright, think of, I know these are both red, but think of one of them being like a green die and the other one a red die. So the green one could be 5 and the red one could be 6, or the green one could be 6 and the red one could be 5. So that's two possible outcomes that make that sum of 11. So that's 2 out of 36, but remember they want you to simplify your answer. So 2/36 reduces to 1/18. Alright, what's the probability of getting a sum greater than 7? Alright, so greater than 7, none of these count. 2, 3, 4, 5, 6. 7's not greater than 7, so we're only looking at the 8, 9, 10, 11, and 12 sums. Alright, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of the 36 that satisfy that. So 15 out of 36. Alright, and then don't forget to reduce. These are both divisible by 3, so 5 over 12 when we reduce it. Alright, what's the probability of getting a sum less than 9? Less than 9. So what satisfies less than 9? 8 and all the way down. Alright, so count all those things up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 26 of the 36 satisfy less than 9. Alright, always remember to reduce. So dividing that by 2 gets me 13 out of 18.